All right, so we're going to look at white page 89 to start talking about scatter plots. This is how we can graphically represent data that has two values. So when it has an X and a Y, or two things that are correlated that we're trying to graph or depict, we can use a scatter plot. So we're going to start talking about a scatter plot in terms of we can make them ourselves. So we're going to make one using this example. So the table below gives data relating to the number of oil changes per year compared to the cost of car repairs. Plot the data on the grid provided. Be sure to label all axes, include a title. The x-axis should be the number of oil changes. So it wants our x-axis to be the number of oil changes a year. And we're just going to number this, right? It goes, our lowest is 0, our highest is 10. So it looks like I could fit if I skip. Okay. So then that means that this is going to be our cost of repairs. And we have to make it to $700 is our highest, so we'll count by 100. 200, 300, 400. We'll call this yearly oil changes. All right, so we've labeled our X and our Y axis. We have a title on our graph. And so now we're just going to plot each of these points that we see. So the first one is 300. So we'd go to 3 to 300. Then 5, 300. Then 2, 500. 3, 400. 1, 700. Okay, so I plotted these points just like I would plot anything on an XY plane. So I plotted all of my data, and we can see that this data it looks pretty linear, right? It's working its way down. We're going to look at scatter plots and how correlation affects our scatter plots. But we can say this one has a pretty linear trend, right? If I put my pen like this, most of those data points are falling on or along that pen. So we describe that as fairly linear. And then if you think about slope, right? If you remember back to your Algebra 1, Algebra 2 days, if I have a line that's going, let's say, roughly like this, right? This would be a negative slope. So our graph is fairly linear with a negative slope. Okay, so what we want to do actually with our scatter plots, especially when they are linear, is we can find a line that best fits them. It's called the line of best fit. And what it is, it's just a line that best describes all of the data that you could use then to make future projections or predictions about other numbers of oil changes and the cost. If I wanted to know, on average, how much would I pay? My line of best fit can help me figure that out. So what we want to do is actually figure out what's the best line that represents this data. So to make a line, we would need to look at 2 points that represent the line that we made. So I'm going to use the point 2, 500, because that went through pretty closely to my graph. And then, like, my line might not be the best. It's kind of low, but let's use 2 500 and 6 100. That's pretty close to my graph, so we'll use these ones. So 2 500 and 6 100, I'm going to use as my 2 points that kind of fit on the line that I estimated when I drew it. Okay, so then let's flip our paper over and see what we can do with that information. So we had our 2 points, and we may want to write them at the top again because we're going to use them here, right? 2 500, is that right? 2 500 and 6 100. So we're going to use those 2 points to find the slope. So remember our equation from slope from Algebra 1. This is x1 and y1 and x2 and y2. I would do 100 minus 500 over 6 minus 2. So what I end up here, negative 100 minus 500 give me negative 400 divided by 4 would end up giving me negative 100 over 1, or just negative 100 when I simplified. All right. So then I'm going to use that slope and one of the points to find the y-intercept. So if I know now, right, this was the slope that I found, that's the m value. So I have y equals mx plus b is our linear equation. I know that my slope is negative 100. I also know that I have an x and a y here and an x and a y here that I can use. It doesn't matter which one that you use. You're going to use one of those to help you find your point. So I'm going to use this one. So my y value was 500 and my x value was 2. So 2 times negative 100 gives me negative 200 plus b. So when I solve for b, I get 700, right? I would add 200 to both sides. So my real equation of my line would be y equals negative 100x plus 700. This would be the line of best fit that describes my data the best. So we're saying that then from this information, we would be able to make predictions or conclusions about what this means or what this can tell us about the data that we have. So if we think about our slope, right? Our slope was negative 100 over, or negative 100 over 1. So then if we think about, right, this represents your change in y over your change in x. So that means your change in y was the total the cost of repairs. Your change in x was the number of oil changes. So what this tells us is as your number of oil changes goes up, your change in cost repairs goes down by 100. So for every oil change, you get, right, when we increase our y value, the cost of repairs goes down by $100. Right? So if this went up to 2, this would be negative 200. So your cost would go down 200. If this went up to 3, this would be negative 300. So then it wants us to explain the meaning of our y-intercept in concept of the problem. So that's when the y value when x is 0. So we found our y-intercept to be 700. So that's 0, 700. Your x value is 0. Your y value is 700. So now remember, x represented your number of oil changes, and y represented your cost of repairs. So what this means is if I got 0 oil changes, I would expect to pay $700 in repairs. Okay. So then just some last things. What we can do with this equation, this line of best fit that we found, and the reason this line of best fit is so nice is we can use this to make predictions about what our expected cost would be or how many oil changes we would have gotten. So it says use algebra and your equation. So remember your equation is y equals negative 100x plus 700 to find the expected cost of engine repairs for 6 oil changes. So what you need to figure out is, are they giving you your x variable or your y variable to solve for the other one? So oil changes, right? Oil changes was our x variable. So this means x equals 6. So if I know that x equals 6, I can then solve for y. So negative 100 times 6 would be negative 600 plus 700 is $100. So if I got 6 oil changes, I would expect $100 in engine repairs. Yeah, if I'm just based off of my line of best fit, this is the prediction that I would make. So then I could go the other way, right? Use your equation, y equals negative 100x plus 700, to find the expected number of oil changes if there was $500 in total repair cost. So if I spent $500 in repair, right, that means y equals 500 this time. And I'm going to go ahead and solve for x. So I'd subtract 700. And then I divide by negative 100. So I get x equals 2. So with $500 in repair cost, I expect that I got 2 oil changes that year. Okay, so this back is really helpful. This is the kind of stuff that we're going to be able to do with our line of best fit. The nice part is we don't have to calculate the line of best fit every time ourselves. And in the next video in our notes, I'll show you how the calculator can show that information for us to give us a more accurate line of best fit to then draw more accurate conclusions. So go ahead and check out the next video.